Hey everybody, how's it going? This is NEcology, which is how I'm choosing to pronounce that. NEcology, first things first, portmanteau of New England or Northeast and ecology. This channel is going to be doing a sort of a peer-to-peer education thing. Forget about college. You don't necessarily need it in every case to learn something. You can educate yourself and then educate others, which is something that I've recently, and by recently I mean within the last year, if not more, have realized is an important aspect of utilizing the internet and utilizing the resources you have provided to you. We're just looking at plants, it's not rocket surgery. No one's life necessarily depends on this, so we're allowed to make mistakes here. We're allowed to learn, and I most certainly will be making mistakes as this channel goes on, which I feel is an important place to put a disclaimer. First and foremost, less than 2 minutes into this video, if you're on this channel because you're looking to identify some plants to eat them or to use them as something, this is not the channel for that. I will not be guaranteeing that absolutely anything is safe to eat. I mean, maybe in the rare case I come across something like a blueberry, something I'm absolutely positive I might eat it, but you'll see me eating it, so that will affect me too. So there's some motivation for me to make sure that when I do pretend like I know what I'm talking about, I actually know what I'm talking about. Also, probably something we should get out of the way first. What exactly is ecology? Well, the dictionary definition of ecology is the branch of biology that deals with the relationships of organisms to one another and to their physical surroundings. Now, obviously, this channel, well, maybe not obviously, but this channel will have a predominant focus on plant life, specifically that plant life which is native to the Northeast. Why am I doing this to you? You're probably thinking, well, it's frankly because it gave me, during the COVID pandemic, something to do, something to look at and understand while I was outside, and just generally a newfound appreciation for the world around me. Plants inform us of animal life, they inform us of geology, they inform us of soil chemistry, they teach us so much about the world around us, and I just think that that's a wonderful thing. Now, this is not a channel to go to if you're interested in gardening, not a channel to go to if you're interested in houseplants. Uh, I can explain. Not really a channel for horticulture in general. We're going to be focusing a lot more on plant life in situ, which basically means in the original place. That's a Latin term. I'm going to throw terms out here. Somewhat rapid fire. The later videos will probably be like that too. Eventually I'll clean up the style, but bear with me for the time being. So again, why am I doing this? Well, basically this was my COVID thing. This was the thing I got into during COVID. I started watching channels, I started reading stuff, I started buying books, all about the ecology of plant life. And frankly, there's not much about the East Coast at all. I mean, certainly not the Northeast, certainly not the area around, some of the biggest urban centers in America. Everybody is interested in, the cacti down in the Southwest, or succulents that live halfway across the world, or just tropical plants or carnivorous plants. And that's all fascinating stuff. But what about stuff that Bostonians can go out and see in their backyard? What about stuff New Yorkers can go out and see in their backyard? I grew up here. What about stuff that I can see in my backyard? It was pretty cool learning about plants in the desert, hundreds of miles away from here, as some of the videos that I was watching were showing me, but I couldn't find anybody doing this from here, at least not in an interesting way. Now, I'll say that now is a good point to clarify what my background is. I know I said screw college, but I did actually go to college. I hold a graduate degree. However, that graduate degree is in psychology. But themes that I found in my study, and I will further clarify that my specific branch of psychology is something called community social psychology, which is the study of community behaviors and social interactions, which I attended a great program for that at the University of Massachusetts. But a lot of the themes that we studied actually, believe it or not, relate to plant life. And I'll jump right in here and just, blatantly state the fact that one of the most fundamental aspects of community social psychology is something called the ecological model. And you're just like, wait a second, I thought you were just talking about ecology and how it relates to biology. Yeah, psychology is still rooted in biology at some point or another, and we like to steal. The ecological model is basically how the self interacts with the world around the self. So, how you as an individual exist as a self contained organism, but also as a part of a family unit or perhaps a unit of friends, perhaps, an individual in your workplace, and then ultimately as an individual functioning as a member of your society, assuming you are a functioning member of society, which you may not be, and I would actually be tempted to applaud you for that, but you get the idea. This is basically what we're going to be looking at, but with plants. An individual plant might exist in of itself, but it has an immediate surrounding to it, what soil it's living in, what plants it's cohabitating with, its greater regional context within a region. What's the climate like? What's the weather like? And then ultimately, an even broader sense of, where in the world is this growing? Is it near the equator? Is it near the Arctic? Is it Eastern Hemisphere, Southern Hemisphere? This quite literally can go on forever. And I'll use an example of a wonderful native plant to New England. By no means a rare plant, although I guess in some areas this is endangered. But I will say, just for the sake of the argument, that this plant here, Cypripedium McCall, is by no means rare around here. You can find this in your backyard or at the park in New England if you know where to look, and that's where we get into ecology. So Cypripedium McCall belongs to the family Orchidaceae, the family of orchids, those weird little funky things you can buy at the grocery store and then give to your grandma and watch the thing die after a few days because that's just kind of what they do. This plant does not germinate, which means to basically come out of its seed without the presence of a fungal associate. And the only place that it can find that fungal associate is at the feet of certain trees, like oaks and pine trees. And then those certain trees only grow in certain types of soil. And then those certain types of soil are only found within certain regions. So I'm hoping that you're making the connection here that these plants and the habitats that they exist in are greater than the sum of their parts. Yeah, I also almost died on the hike that I took this picture on. That might be a reoccurring theme. You guys might see me get into some pretty interesting situations. God knows I already have. Well, here's another example of something that needs to exist within a certain context. I mean, you've all probably eaten these before. This is Vaccinium angustifolium, a member of the family Ericaceae. This is not my photograph. I took this from Wikicommons, which is a great resource to use. And basically what you need to understand about Vaccinium, or more broadly just the entire family Ericaceae, is that these plants rely also very heavily on fungus in the soil, and they contribute back to their environment by habitating nutrient poor bogs all around New England. If you live in New England, specifically if you live in Massachusetts, you know all about bogs, and you probably know about cranberries. Cranberries are in the same genus as blueberries. They're both species of Vaccinium. And they both do fundamentally a really similar thing in this nutrient poor bog environment, which is provide nitrogen so that other plants are able to at least get a foothold. And it does that by cooperating with species of fungus. All of this has to occur in really specific environmental conditions, and that's the difference between ecology and just looking at the botany of a plant, or the biological science of the plant as an individual, versus looking at the biological science of it in relation to its environment. I'll backpedal here by saying you're going to see me refer to most of these plant species by their scientific names. Even just blueberry, which you might think is a simple enough one to think of. There's more than one species of blueberry. You have the high brush blueberry, you have low brush blueberry. Vaccinium specifically is a massive genus in the Northeast. There's tons of species of Vaccinium, tons of species within Ericaceae. We'll get into that as we go into the actual video content that will eventually be up on this channel. But going back to this orchid here, so the Cypripedium macaw, which a lot of people know as a lady slipper, these plants will only be found if their environmental requirements can be met. Dirt, sun, water is not all it takes to raise a plant. A lot of plants don't grow in cultivation. A lot of plants, even planted in similar environments or superficially similar, don't grow. With wild plants, you never know what specific thing they might be looking for to basically get their foothold and get their basic needs met. With a lot of plants you find in gardens, these are cultivars that have been selectively bred to be convenient to the human setting, to exist in an anthropogenic habitat, which would be a human-made habitat. A lot of common weeds you see are quote unquote common weeds because they're already adapted to live in that sort of environment that humans create. A lot of the weeds you see growing along your lawn, growing along roadsides, they like those habitats. They're not growing there because they're weeds. For the most part, some of them might be noxious weeds, invasive species, but a lot of them are just able to take advantage of that type of environment. Which brings me to a excellent spot for our next tie into my actual background, and this is Maslow's hierarchy of needs. The ecological model I wish was more taught in Psychology 101. This is something you might remember if you took psychology even in like high school. So this is the hierarchy of needs where from the bottom up you basically have an ascension of what your sense of fulfillment is basically being. The bottom you have, food, water, shelter, warmth, your basic needs for survival. Above that you have security. Above that, social needs, etc., etc. So this ties into basically what plants need. All plants are going to need in some form or another water. They're going to need something to functionally grow on that might not necessarily be the ground. You have epiphytic plants. If you've ever seen one of those hipster coffee shops where they have the tillandsias hanging from the ceiling, that's an example of an epiphytic plant. Lithophytic, meaning the same thing, just growing on a rock. They don't necessarily need a soil substrate, but they do need some sort of substrate to grow on, whether that be soil, water, another plant. Some plants even grow inside the tissue of other plants, which we may eventually talk about. Water obviously being a need. Not every plant sucks up its water through its roots, though. Tillandsia, which are an example I used, actually have modified leaf tissue to do that. And believe it or not, sun is not actually even one of these basic requirements. To a certain extent, it is, and I'll explain why. You have plants that are referred to as achlorophyllous, meaning they do not produce chlorophyll. Rather, they parasitize off of other plants or they parasitize off of fungus. I've got a really cool plant that I'll be able to show you in this slideshow, but it's not native. But also, there's quite a few native achlorophyllous plants to the region that we can get into. But you get what I'm saying. The basic needs need to be met for plants in one form or another. It needs water. It needs something to grow in, and then it needs some way to get energy. You know, and it's not a one-to-one comparison. You have security, you have social needs. A lot of these plants grow in association with other organisms. Perhaps they have a animal that's responsible for its pollination. You might get the plant to grow and to flower and to survive, but without that specific pollinator, that plant won't be able to reproduce. And for some plants, that's not as important. Conifers are generally anemophilous, which means they're wind pollinated. They don't have a specific, pollinator that they need. But at some level, there needs to be something facilitating the reproduction of the plant. It almost actually is a one-to-one tie with that social needs level because they need to have associates. That can go for plants too. Some plants, as I already mentioned, only grow in association with other plants. You have, chemical needs in the soil, you have geographic needs. Perhaps a plant is able to get a foothold in a certain location because nothing else can survive there. If it's a wind-blown, mountain ridge where nothing else is growing but this one plant, hey, that's probably because that plant relies on all those other plants being blown away off the ridge. This does not work as well of a comparison as the ecological model does, in my opinion, but nevertheless, the concept is generally somewhat similar. This is one of the plants I was talking about. I should have put in the plant that I was originally thinking of, the one that's native here, which is actually another member of the family Ericaceae, like blueberries, which would have been Monotropa uniflora, which I will rest assured show you at one point. Wonderful plant, one of my favorites. This is Parasitaxis usta. This is in the Podocarpaceae. Don't worry about this plant necessarily, but this is a highly specialized parasitic conifer, the only one known to exist. It's on New Caledonia. It's an island in the South Pacific, but a very hyper-specific environment is needed for this plant to grow. It does not grow anywhere else in the world. And when we talk about New England, what type of, environments are we talking about? In the top left there, I have a bog, very, very common, in Massachusetts and Maine. Top right is a ridgeline in the White Mountains of New Hampshire, which has its own unique community. Down in the bottom left is Cape Cod with yet another unique community. And then in the bottom left is just a mixed forest like we get, all over the Northeast, which will yet again have its own unique community of plants and animals. Here, just to show you, a little bit more close up what you're looking at, that top left would be, just some loose rocky soil you might see on top of a mountain. Top right is a rich forest soil teeming with different plant life, very competitive and very rich in nutrients. The bottom left is the sand dunes of the Cape close up, poor in nutrients, very, very fast draining, very hostile to a lot of water demanding plants, which creates a unique scenario for many of the plants that try to live there. And then on the bottom right is peat from a bog, which, despite being, very, very moist and surrounded by, different plants and full of organic matter, that's actually a very nutrient poor soil, as I mentioned before. It's an anaerobic community, so bacteria aren't creating nitrogen back into that environment, which is why plants like that blueberry are able to play a very key role in that environment. Like I said before, plants in cultivation and plants in situ are not one-to-one. On the left there, you have a garden full of cultivated rhododendron species, and then on the right, you have a wild rhododendron. That's Rhododendron groenlandicum, which is a species of rhododendron some people might know as Labrador tea, if you're into that sort of stuff. That grows wild on mountain bogs in New Hampshire, and I mean across all of, not necessarily just on mountain bogs, but it grows in cold, somewhat high altitude bogs. It's found in lowlands too, but it does really, really well at the higher altitudes where it's not competing for sunlight with other species. But you can see that in the environment, it does not necessarily look anything like what it looks like in cultivation. Another thing I want to clarify is the fact that what's native to us is not necessarily mean that it's a good or a bad plant. When I say native or invasive, I'm not trying to anthropomorphize things. I'm not trying to make it sound like these are people, like these are things making conscious decisions. These are plants that have evolved over hundreds of thousands, if not millions of years. This is the same species on the right and left. And if you could not tell me in which habitat that plant, which is an opuntia, a prickly pear, is invasive in, I wouldn't blame you, because that's just the nature of things. When something's invasive, it's not nefarious. It's just capitalizing on a similar habitat to where it came from. And if you wanted to know, the one on the left is the invasive prickly pear. That is in Australia, where no cactus is native to. In fact, all but one species of cacti are completely isolated to the Americas, but they've become invasive in other deserts around the world. Carrying on the theme of invasives and plants being able to capitalize on certain types of habitats, dandelion is a really common weed, or so-called weed. A lot of people love dandelions. A lot of people hate dandelions. The matter of fact is dandelions are actually an invasive species to the United States, albeit one that's not necessarily noxious and relatively easy to outcompete. And I'll just say this by saying, how many of you have seen dandelions, growing on your lawn, growing in the sidewalk, but then not growing in the woods? It's because they're able to take advantage of those anthropogenic habitats that I mentioned before, where they don't have to compete for sun. But the second you throw them in the shade, they've got some competition. Dandelions are also part of the family Asteraceae, which is a huge plant family, which there are a lot of lookalikes of dandelions that are not invasive. There are a lot of things people assume are dandelions, but aren't. Not every yellow flower growing out of your lawn is a dandelion. They actually have an expression for these thousands of different species that look like dandelions called damn yellow composites. But we'll get into that at some point in the future as this channel progresses. And I'll just go back to the orchid again. You got to look at where things are growing. Nothing is doing something for no reason. Plants aren't capable of conscious thought. They don't make these decisions. They don't decide to evolve the way that they do. They don't decide to grow in the habitats that they grow in. They do it because they evolve to do this. And it's served some benefit, over time to them. I like to look at adaptations to habitats in the sense of does a plant evolve a certain way because doing so was just generally advantageous to it, or did it evolve that way because it had to? And that's not a great way to think about it. It's not a very academic way to think about it, I don't think. But on the left there, you've got some typhus species, cattails. Obviously, these guys are able to set up shop pretty much everywhere. In ponds and wetlands. They're members of the grass family. They produce a ton of seed. They do what they do very, very well. And then on the right is a species of pitcher plant, Sarracenia purpurea, which is a carnivorous plant. And both of these could be found in a similar environment. Obviously, one is this massive dominating plant that just, completely fills out the landscape that it grows in. And one's a small little guy just growing close to the ground. And these both these plants have evolved completely different adaptations for doing what they do. Specifically with the Sarracenia purpurea, I've already mentioned that there are environments that are extremely nitrogen poor, extremely nutrient poor. It adapted its adaptation because it needed a way to basically get nutrients, and it wasn't getting them from the soil. Another key thing to point out just while we're doing this general crash course is that you'll have stuff that looks almost identical but has no relation to each other at all. I just said that there are no cacti native to Africa, Asia, Australia, wherever. They're only native to the Americas, and there are already people with house plant collections that are saying I've got like a African milk cactus or whatever the heck they're called. Cacti. And a spiny succulent form factor has evolved numerous times in different families. On the left there, we've got an actual cactus, a member of the family Cactaceae, which is in the order Caryophyllales. And then on the right, you've got a species of Euphorbia, which is in Euphorbiaceae, which, of course, is not at all related to the family Cactaceae. But they had similar environmental pressures, so they involved a similar form factor because they're fundamentally doing the same thing. Some of you may have heard the term convergent evolution, the process whereby organisms not closely related independently evolve similar traits as a result to having to adapt to similar environments or ecological niches. So this might seem dry, this might seem a bit boring. The actual form factor that these videos are going to take is going to be more so the going out into the field and just looking at stuff, which will be not edited, not slideshows, probably about as long as this, but a lot less boring. And even though I'm not taking you to see all this crazy stuff in tropical environments, I'm making a point to show you things that are native to an area that is near me that I didn't have anybody making videos about, plants in my own backyard. I wish I did, but I didn't. Parasitaxis usta would be really, really cool to see in person, but I can't fly thousands of miles to the tropical island of New Caledonia to show it to you. I can't fly to South Africa to go look at succulents in their native habitat. I can't fly to Australia to go look at, other members of the family Podocarpaceae, to look at other weird southern hemisphere plants that we don't get anything similar to them up here in the northern hemisphere. You know, uh, I'm sorry that we don't have cacti. Oh wait, we do. I'm sorry we don't have carnivorous plants. Oh wait, we got a lot of those actually. But we do have lots of really cool endemic species. I wouldn't blame you if you've never heard of any of these because they're quite rare and they're quite hard to find, but they don't exist anywhere else in the world except for New England. On the left there is Liatris novo Angliae, which is the New England shooting star. I'm sure some of you were like, hey, I know I've seen that plant before. Yeah, you've probably seen Liatris spicata, which is a very, very popular garden plant. It's not native to New England, it's native to the Midwest. Same genus, different species. The Liatris that we get up here is endangered, very, very rare. Found in a lot of coastal areas because it can withstand sea spray. There's some beautiful fields in Maine where I plan to go see that up near Kennebunk. That plant in the middle is the holy grail of New England endemics. That's Potentia robinsiana, a plant that was down to just a few hundred individuals at one point in the 70s, found only on Mount Washington, with a very small number of individuals allegedly also present on the Franconia Ridge, a couple of transplanted populations, but generally speaking, the only place in that world and the only place in the world you're going to see that plant is on Mount Washington, in the col between Mount Monroe and the summit of Mount Washington. The only place in the world that that plant grows. And then on the right there is one that I actually took. I took that picture. That's GM Peckii, which is another, I guess you wouldn't say endemic, but near endemic species, known only from the White Mountains in New Hampshire. And then I guess there's a small population of them on an island off the coast of Nova Scotia. So we do get plenty of our own interesting things to look at up here. And endemic means native and restricted to a certain place, if I did not explain that. So we're going to look at a lot of different stuff. We're going to be out in the field. We're going to go to the White Mountains of New Hampshire, Green Mountains of Vermont, the bogs on the seacoast of Maine, bogs in Massachusetts, Cape Cod's going to have interesting stuff. Just all over the place, there's unique habitats. New England has a really varied climate. New England's climate goes everywhere from subarctic to subtropical. You get a lot of variation between, coastal Connecticut and standing on top of Mount Washington. Probably a 3-hour drive from New Haven to the top of Mount Washington, but the climates could not be more different, like worlds apart. We're going to get into that. We're going to do an introduction to the geology of the region, the different types of rock you get, the different types of habitat. It's just too deep to go into what's already turning into, a very, very long introduction and channel primer. One of the first videos I do have planned is going to be talking about this guy, Symplocarpus fetidus, the skunk cabbage. Some of you may have heard of it. A lot of people don't see what it looks like when it flowers. They only see the actual leafy part in the summer, long after it's already flowered. As I'm recording this video, it's March. I already got a picture of this guy last month, just starting to open up. Unfortunately, it snowed a bunch on us in between when I took this picture and now. So maybe in a couple weeks, I'll be able to go out and film the first video. It'll be about this guy. I'll probably cover some of the native conifers, the white pines, different members of the Cupressaceae family that we get up here, because there generally probably won't be that much to look at early in March. But I've got some recommendations for some stuff to look at too in the meantime. Number one, first and foremost, go check out the channel Crime Pays, but Botany Doesn't. very, very key player in getting me into this sort of thing. The guy runs probably the best botany channel on YouTube. Uh, he covers more stuff from the West Coast, stuff from the Midwest. He's gone out to other countries. Does nothing that he's done up here in the Northeast so far. Maybe someday he will, but for now, I'm taking the reins up on that one, directly inspired by him. I'm going to cut to a clip of me going through some books right now. Okay, you're going to want to get yourself some books too, because reading is important for this sort of thing. Um, I got a handful here that I've picked out. Uh, Simpson's Plant Systematics is pretty much the holy Bible of, plant evolution, plant taxonomy. Uh, Make sure you get the most up to date version of a book when dealing with botany because these taxa are fluid. This is a science that's still changing. Uh, Nothing is set in stone as they continue to do more research, as they continue to, discover new species. So generally speaking, when you go with a botany specific textbook, you want to get the most recent version. And this book by Simpson, Plant Systematics, I got the third edition. I think this maybe came out maybe 2 or 3 years ago. I'm not quite sure. Also, by used, I haven't bought in a single one of these books. Actually, that might not be true. I think I got this one new. And I definitely got this one new too. But anyway, these are like $100 new. I paid maybe 40 or 50 bucks for it, or you could probably just find a PDF online. I highly recommend this one. I actually don't really recommend starting with this one because this book is extremely detailed and verbose and technical, and if that's just not your thing, if you don't like reading textbooks, you might want to warm up to this one. I personally started with this one, Botany in a Day. Also the most recent copy. This is more so tailored to Western North America as opposed to Eastern North America where we are. It's also quite a bit less technical. It's a good primer for botany. Good primer, just if you're just getting into it. This is approached from the perspective of herbal medicine, foraging. So it's not my cup of tea per se. A lot less focused on systematics and evolution and taxonomy, a lot more focused on identification in the field and whatnot. I asked for this book. Somebody gave this one to me. Native Plants of the Northeast, a guide for gardening and conservation. Red flag right there. No offense to Leopold, the guy who wrote this. I'm positive he knows what he's talking about, but if you go through this book, it's got some good information at the beginning about, conservation, reforestation, soil types, what is a good one. That's Speary Alba. I've seen that one out in nature. I think I put that one in the video. If not, we'll be seeing that one for sure this summer. But it's got a good preface for soil types and planting, but this book is not organized in any way, even remotely conducive to studying this stuff. From a scientific perspective, it's listed in alphabetical order by species, not listed by. See, look, we go from an aster, Solidago. Okay, there's Solidago, Asteraceae, and now Loginiaceae, Papavervaceae, where you will jump back and forth between different plant families in this. Not really informative as to why things are grouped together. I won't even spend that much more time talking about it. It's a book for gardening, which is fine if that's what you're into. And actually, I would recommend this one if you do want to get into gardening. A lot of the plant families are well, not a lot of them. A few of them are wrong, or it's just not an ideal book for studying this stuff from a scientific perspective. You're much better off sticking with these two. Of course, you probably also want to get, these would be considered field guides. So whereas, this, I guess you could say, is somewhat of a mix between field guide. They do get into some taxonomy stuff and some systematic stuff, and it's a good primer. This obviously goes very, very in depth, chronologically through the evolution of plants. So you start with, algae, and then you jump into the non-vascular plants. Liverworts, mosses. You get into ferns, gymnosperms, conifers, and then all the way up to monocots of the flowering plant families, eudicots. Great book, complex though. If you're intimidated by it, I wouldn't blame you. These are field guides, and these are a lot more. Obviously, you can see a lot smaller. I mean, you could put this right in your backpack. Um, and these are great for if you're out in the field and you just trying to figure out what you're looking at. This is a great book for that. This one doesn't just have plants in it. This one has some basic geology. This one has some of the basics of plant life. I mean, a lot of these I've seen a lot of these plants out in the field. Some of these are in the video. You get the Canada bunchberry there, one of the dogwoods. Yeah, I've seen that mountain sorrel too. It's edible. I've eaten that. Uh, you know, Giampecii, I put that in the video. That's a rare plant that I found. I got the robin cinquefoil up here. Hoping to go see that one on, not only from 2 locations in New Hampshire, hoping to go see that. But this one's a great one. If you just want a crash course for a specific area, this one, of course, obviously New England Alpine Summit's right up our alley. Trees of Eastern North America, same deal. Well organized by order and family. This one's got a great table of contents. In this, a lot of the field guides will have stuff like this where it's just showing what am I looking at. I just want to figure out what I'm looking at right now, really quick. These are more useful for that sort of thing. And then, of course, as you progress through, you're going to want to study geology, probably mycology too, just to learn about this. In mycology, you want to approach the same way as you approach the plant textbooks. You definitely want to get the most recent and most up-to-date books you can, because subject to change. However, with geology, that's not necessarily the case. A lot of this stuff was figured out and has remained pretty stable. This is just any college level introductory geology textbook will probably be fine. I already shouted out Crime Pays, but Botany doesn't. He has a great reading list of like 60, 70 books that he's gone through. Not all of them are going to be applicable to us. Like these two are two of the books he basically says to start with, and not so much this one anymore, because I guess this I don't actually know. I mean, it's maybe not as useful. I'll admit it's not as useful as this one as far as understanding the complexities of it, but it's fine if you're just trying to get a basic understanding. This is great. This was cool. This actually isn't a textbook. This reads much more like a storybook, but a very informative one. And this is basically the geological history of the northeastern U.S., which is quite fascinating. This has gone on long enough, but it's an important part of getting up to speed on this. And we're going to go to the next thing. There's a couple of good websites to go to. iNaturalist is a great website. That's where I post a lot of the photographs I take of species. Really helpful in identifying and looking at distribution for species. I'll put a screenshot of the website up here, but I just go and look at it, make an account, scroll around through it. You can look and see what people have spotted down the street from you. Make an account for it, start taking pictures of stuff. Even if you don't know what it is, you can put it up there and people can help you identify it. It's not just for plants, it's for animals, fungus, even like microorganisms you can put up on there. GoBotany.com, which is another website, I'll put a screenshot up for that too, is a great resource for New England plants. It only really covers New England plants. It's organized by family and by genus. I wish that they organized it by order, but the website is still under development. You get curious about a species that you've identified, you can go there and you can search it up. It'll give you really detailed information, county by county in New England, of where it's found, what its historical status was. Was it extirpated? Did it have a range expansion? Is it a non-native? There's some weird distribution patterns with some plants that we'll see, but that website's a good place to go to kind of get your sink your teeth into it, if you know what I mean. If you just want to start just browsing stuff, I recommend you go there and you just start browsing around different pages. familiarize yourself with some genuses, familiarize yourself with some of the distribution patterns that will be common. Is it relegated to the mountains in the north and in the west? Is it only along the seacoast? Is it clinging to the southern corner of New England where it's warmest? You'll start to piece together patterns and stuff like that. All right, well, this video is going to end up being like 45 minutes long. Unfortunately, I did not intend for it to be that long. If you've stuck around this far, thank you. Please be patient. Actual content that's hopefully enjoyable to watch will be coming. I just wanted to give everybody a crash course in what to expect, what this channel is going to look like, what we're going to do, give you some resources, and give you some really, really basic, fundamental ecology terms and ecology principles to work with. Uh, I did the music for this channel. I will continue to do the music for this channel. I might put links down below. I don't actually know what it's going to look like down there right now in the description, but thank you for sticking around. Please come back in the future when there's more content up, and have a great day.